The spring of 1967 was not a time of overt crisis, but of cold, grinding routine along the Soviet Union's western frontier. The airbases and radar installations lining the Baltic Sea, from the frozen expanse of the Gulf of Finland down to the Polish border, were the sharpest point of the Iron Curtain, manned by young conscripts and veteran officers conditioned by years of relentless vigilance. This was the front line where the Soviet Air Defense Forces (PVO) played a perpetual, deadly game of cat and mouse with NATO reconnaissance aircraft, the elusive RB-47s and the high-speed, high-altitude State Route 71 Blackbirds that occasionally skirted the periphery. But while the routines were cold, the air was crackling with the heat of technological ambition. The Soviet Union, still riding the psychological high of Sputnik and Yuri Gagarin, was pouring an incomprehensible portion of its national wealth into the military-industrial complex. The mantra was simple: parity with the West, and then absolute superiority. The quiet watch in Klaipėda. The key observation post for the incident was the long-range radar installation near Klaipėda, Lithuanian SSR. The air inside the low-slung, reinforced concrete bunker was thick with the smell of ozone, stale tobacco smoke, and the constant, high-pitched whine of the massive P-14 feet tall King, early warning radar rotating above. On the night shift, the young radar operators often stared at the vast, green sweep of the Plan Position Indicator (PPI) screen, the scope reflecting their tired faces. The screen was usually empty, save for the predictable clutter of maritime traffic in the Baltic and the occasional, slow-moving commercial airliner destined for Moscow. At 3:41 hours, according to the duty officer's log, the predictable pattern shattered. First, there was a blip, a single, powerful return on the edge of the radar horizon, appearing at an improbable speed. The initial contact point was over international waters, near the Swedish island of Gotland. The young operator, Sergeant Dmitry Ilyushin, a graduate of the Riga Military Aviation School, initially tapped the console, convinced of a momentary voltage fluctuation or a software aberration. He had never seen a return spike so intensely, or move with such brutal velocity. Before he could log the contact, the blip elongated into a streak. On the PPI scope, the return was not moving like a conventional aircraft. A MiG-21 feet fishbed, the fastest operational fighter in the PVO, would traverse the screen with a distinct, measurable series of jumps, each jump corresponding to a sweep of the radar antenna. This target moved like a line drawn by a ruler, impossibly fast. The sheer speed of the object meant the radar antenna barely had time to register its presence before it was gone. Then, nothing. The streak evaporated. The scope returned to its normal, hypnotic green sweep, as if the intrusion had never occurred. The air was thick with the metallic aftertaste of burnt ozone, a sensory side effect of the radar's struggle to resolve the impossibly fast object. Sergeant Ilyushin, pale and trembling, checked the tape recorder logs. The entire event, from initial blip to complete disappearance beyond the tracking limits of the tall King, lasted only 47 seconds. The mathematics of the impossible. The command staff, rousted from their beds, immediately analyzed the data. The tall King radar had an operational horizon that spanned approximately 450 kilometers at the target's presumed altitude. To traverse that entire distance, a quarter of the way across the Baltic, in just 47 seconds demanded a simple, terrifying calculation. The object was traveling at an average speed of 9.57 kilometers per second, or approximately 34,500 kilometers per hour. This was mathematically absurd. At the time, the fastest operational aircraft in the world was the American State Route 71 Blackbird, capable of sustained speeds just above Mach 3.3, around 3,500 kilometers per hour. The Soviet Union's fastest operational jet, the MiG-21, could push to Mach 2.0. Even the mythical Soviet interceptor, the still-secret MiG-25 feet Foxbat, which the West believed was capable of Mach 3, was still confined to an air-breathing envelope far below this speed. The speed recorded by the tall King was not merely fast, it was orbital velocity. If the object had truly covered 450 kilometers in 47 seconds, it was moving at a speed associated with the Soyuz space capsules, not an aircraft. To the operators, staring at the hard numerical evidence, it looked like a glitch in the aging magnetic tape recorder, or a deep, embarrassing software error. The chief intelligence officer on site logged the incident as a probable, false positive due to atmospheric anomalies and electrical interference. It wasn't. The report was immediately flagged by the KGB's 3rd Chief Directorate, Military Counterintelligence, and sent straight to the Mikoyan-Gurevich Design Bureau OKB 155, bypassing normal PVO channels. The eyewitness account, Daugavpils, hundreds of kilometers away, the impossible was confirmed by the oldest, most reliable sensor available, the human eye. The Daugaspils Air Base in Latvia was home to the 1st Fighter Aviation Regiment, flying the ubiquitous MiG-21 PFM interceptors. The aircraft were housed in hardened concrete shelters, ready for immediate scramble. The commander of the squadron, Major Vladimir Rostovsky, a highly decorated pilot with 1,500 hours in the MiG-21, was on the tarmac, conducting a routine pre-dawn inspection of the runway lights. The silence of the base, punctuated only by the distant wash of the Baltic, was shattered not by sound, but by an extraordinary visual phenomenon. Major Rostovsky's official logbook entry, written later that morning, a document that would become a key piece of evidence in the Western intelligence file, Project Crimson, was marked by utter bewilderment. 0342 hours. Observing runway light pattern, clear visibility, horizon perfectly black, we were passed by something that looked like our aircraft, but wrong. Too fast, too high, no sonic boom, no contrail, just a flash. Rostovsky described the sighting in excruciating detail to the debriefing officer. The object was visible for perhaps a second and a half. The appearance. It possessed the general profile of a Mikoyan jet, the sharp nose, the delta wing, but was clearly larger, more aggressively contoured, and darker, almost black. It was not a NATO aircraft. Rostovsky was certain of the general family profile. The silence. Crucially, there was no sonic boom. Any aircraft flying at Mach 2 or 3 would generate a deafening thunderclap at that altitude. The air remained silent. The only acoustic signature was a faint, sharp hiss that seemed to vanish instantly. The contrail. There was no contrail. The white condensation trails typical of aircraft operating in the high, cold atmosphere. What Major Rostovsky saw was not a UFO. It was their own aircraft, a product of the Soviet military-industrial complex that was so far beyond the established limits of flight. It appeared supernatural even to the pilots of the PVO. The immediate response. Sanitization and silence. The official Soviet response was swift and draconian. Within 48 hours, both the Klaipėda radar bunker and the Daugaspils airbase were flooded by internal security teams. The Klaipėda log entry regarding the false positive was erased and replaced with a forged entry citing scheduled maintenance blackout. Sergeant Ilyushin was transferred to a remote Arctic outpost, his career effectively terminated. Major Rostovsky's logbook was confiscated, and he was subjected to days of intense, repetitive psychological debriefing, designed to instill the memory that he had seen a meteorite fragment breaking up in the upper atmosphere, nothing more. The aim was not merely to maintain military secrecy, it was to perform a psychological sanitization. The existence of the aircraft was so sensitive, so strategically devastating to reveal, that even the men who witnessed its accidental high-speed pass had to be convinced they were wrong. The machine the Soviet Union had tried desperately to hide, and even more desperately to control, was now a security leak that threatened to unravel decades of deception. The jet that defied its own designation. The object seen by the radar and the pilot was the result of a secret and increasingly desperate research program initiated by the Mikoyan Design Bureau in the early 1960s. The program's goal was to create a high-altitude interceptor capable of catching the fastest U.S. reconnaissance platform, particularly the State Route 71 Blackbird, a plane the Soviets called the Flying Menace, and to deliver a new generation of heavy, nuclear-tipped anti-aircraft missiles. But the ambition outstripped the engineering. The obsession with speed led to radical, often reckless, design choices. The actual designation of the jet remains one of the Cold War's most fiercely guarded secrets, often obscured by intentional Soviet disinformation campaigns that led the West to wildly overestimate the capabilities of its eventual, slower successor, the MiG-25. The machine seen over the Baltic, the true, first-generation prototype, was internally referred to by its engineers by a simple, terrifying code, Project 25.1 or sometimes, darkly, Grozny, the Terrible. The true designation of the operational version, still shrouded in layers of partial declassification and rumor, can only be stated as the MiG _____. It was the jet that flew too fast. Too fast for its own engines. The immense heat and pressure generated by the twin, experimental R-15 turbojets at their operational limit caused the engines to essentially melt themselves, turning the machine into a self-destructive projectile. Too fast for its own airframe. The friction and dynamic pressure created structural instability, thermal warping of the skin, and a frightening, low-frequency flutter that threatened to tear the wings clean off. Too fast for the pilots imprisoned inside it. The G-forces generated by the smallest directional change at Mach 6, the theoretical speed implied by the radar signature, were lethal. The physiological limits of the human body were the ultimate, unbreakable constraint. The speed recorded, The Mach 8.8 was not its sustainable cruise. It was a terrifying, momentary thrust achieved by pushing the engine past its safety margins, an accidental demonstration of a catastrophic potential. The MiG___ was an engineering declaration. The Soviet Union had built a machine that had successfully overcome the obstacles of conventional aviation, only to run headlong into the ultimate, unforgiving wall of physics and human biology. And for NATO, the existence of this jet, this crimson streak that left no sound or contrail, represented a capability far too dangerous to ever face in battle. It wasn't just a plane, it was a self-destructing projectile, a symbol of reckless Soviet ambition, and a threat that had fundamentally altered the balance of power in the skies over Europe. The question was not how to shoot it down, but how to survive its inevitable, lethal presence in the air. The chilling 47-second transit of the MiG_ across the Baltic radar screen in 1967 was not a random technological anomaly. It was the calculated, desperate, and ultimately reckless answer to a strategic humiliation that had burned deep into the Soviet political and military psyche for nearly a decade. To understand the MiG__, the machine that flew too fast for its own survival, one must first understand the crushing pressure under which it was conceived. That pressure came directly from the high-altitude, silver-winged specters of American ingenuity. The Oxcott and the Blackbird, the ultimate humiliation. The initial seeds of the Soviet obsession with hyperspeed were planted in the late 1950s and early 1960s with the deployment of the American Lockheed A-12 Oxcott, the secretive predecessor to the much more famous State Route 71 Blackbird. In the early 1960s, Soviet radar operators, particularly those covering the Central Asian borders, began reporting contacts that defied logic. These targets were not only flying at phenomenal speeds, later confirmed to be in excess of Mach 3.2, but they were also operating at altitudes well above 85,000 feet. At that height, the air density is so low that conventional Soviet interceptors, like the MiG-21, effectively become bricks. They simply could not maneuver, let alone accelerate to intercept the American intruder. The State Route 71 was more than a reconnaissance platform, it was a physical statement of American technological untouchability. The Soviet Air Defense Forces (PVO) threw everything they had at the problem. Fighter pilots scrambled, their jets laboring against the thin air. Surface-to-air missile (SAM) crews launched their massive S-75 Dvina SA-2 missiles, the same type that had brought down Gary Powers' U-2, but the missiles struggled to maintain trajectory and velocity at such extreme ranges. The Americans were simply too high and too fast. They would fly in, photograph sensitive nuclear sites, map strategic military corridors, and vanish again, leaving behind a baffled, humiliated air defense system. The Kremlin demanded an answer. This was not merely a military necessity, it was a matter of ideological prestige. The Soviet Union could not, under any circumstances, allow capitalist technology to demonstrate such clear, unchallenged superiority in the air, the domain they had so proudly claimed with the first Sputnik. The directive that cascaded down from the Central Committee and the Minister of Defense was stark. The Soviet Union must produce a plane that could not just compete with the SR-71, but utterly eclipse it. The mandate of superiority, the demand was not for a competitor, a jet that could merely match the SR-71's speed. Nor was it for a countermeasure, a ground-based missile system to passively defeat the intrusion. The demand was for a superiority statement. A machine that would instill the same fear and awe in the Americans that the Blackbird had instilled in the Soviets. The new jet had to be capable of sustained high speed, rapid climb, and most importantly, it had to be able to overtake the SR-71, a feat considered impossible by aerospace engineers globally. The challenge fell to the legendary Mikoyan-Gurevich Design Bureau (OKB 155), the masters of high-speed Soviet jet design. The chief designer, wrestling with the impossible brief, knew that conventional aerodynamics and engine limitations meant the task was hopeless. The team faced a choice: design a better aircraft, or design a faster engine. They chose the latter, committing to a design philosophy that was both radically simple and terrifyingly ambitious. The engine-first philosophy, a jet built around the fire. Mikoyan's proposal was a departure from standard aircraft design, which typically balances aerodynamics, payload, and power. Their proposal was simple: a jet built around enormous engines. The engine chosen was the immense Tumansky R-15. This was not a refined, efficiency-driven turbofan, it was a pure, brutal afterburning turbojet, originally intended for a long-range cruise missile. It was a beast of an engine, designed to run hot, loud, and for a limited number of cycles. McCoyan's plan was to take two of these monsters, strap them together, and push them far beyond their intended operational envelope. The radical principle was one of total reduction. Everything else, wings, fuselage, cockpit, would be minimized to the barest skeleton required for survival. Wings. Minimalist delta wings were chosen. They were not designed for low-speed maneuverability. Dogfighting was impossible at these speeds, but merely to generate enough lift to get the vehicle off the ground and to provide stability at hypersonic cruise. Fuselage. The body was designed as a giant, rigid duct to efficiently channel air into the immense engine intakes, maximizing ram compression. It was a giant conduit for propulsion, not a streamlined vessel for human beings. Cockpit. The pilot's position was considered a necessary evil, a piece of non-essential equipment that sadly required life support. Protection and comfort were sacrificed for structural integrity and thermal shielding. The MiG was designated a fighter, only in name, to satisfy the military procurement bureaucracy. In truth, it was a missile with a man inside. Its mission profile was singularly brutal: intercept anything, anywhere, at any altitude. But the unspoken, real mission was to achieve speeds that the State Route 71 could only dream of. The target speed was not Mach 3.3, but to push the limits of Mach 4, with a terrifying, theoretical maximum approaching Mach 6. The unforgiving wall of physics. At the speeds McCoyan was pursuing, air itself ceases to behave like a fluid and begins to act like a solid, crystalline wall. The aircraft was not just flying, it was tearing a path through the atmospheric boundary layer, generating phenomenal stress, vibration, and heat. This ambition brought the engineers face to face with the unforgiving wall of physics. The problems encountered were not matters of fine-tuning, they were fundamental barriers that threatened to destroy the aircraft mid-flight. The primary problem at Mach 3 and above is kinetic heating. Air compressed by the aircraft's speed and friction heats up dramatically. The temperatures generated on the leading edges of the wings and the nosecone were projected to exceed 500 degrees. The effect on the pilot's environment was lethal. The internal structures of the fuselage acted as a giant, pressurized oven. The cockpit, despite layers of insulation, would rapidly approach 270 degrees Celsius, far above the point at which human flesh is instantly cooked. The pilot wasn't flying, he was being parboiled inside a metallic sheath. To mitigate this, the engineers made a desperate choice. Instead of using expensive, heavy titanium alloys, which the Soviets lacked in sufficient quantity and quality, they built the main structural elements, including the fuselage and wing spars, out of nickel steel alloy. This made the aircraft enormously heavy, but it was cheaper and more readily available, and it had a slightly higher tolerance for prolonged heat than aluminum. The core of the problem lay in the engines themselves. The R-15 turbojets relied on intricate compressor and turbine blades, traditionally made of high-temperature titanium and specialized steel alloys. But the air entering the engine intakes at Mach 3.5 was already scorching hot, and the internal combustion process raised the temperature exponentially. The intense, sustained heat at the rear of the combustion chamber threatened to destroy the engine from the inside out. In the simulation labs, the engineers watched their high-tech alloys deform, lose their structural integrity, and eventually liquefy, turning the turbine section into molten slag. The solution: radical internal cooling systems that pumped specialized cryogenic liquids through the structure, consuming fuel and severely limiting the engine's lifespan to just a few hours of high Mach flight before total replacement was mandatory. The fuel itself, a high-energy kerosene known as T6, became another dangerous variable. At high Mach numbers, the air entering the fuel tanks was heated by friction, and the air used to pressurize the tanks became dangerously hot. In ground tests, engineers observed a terrifying phenomenon. The fuel vapor, compressed by the intense heat and pressure, would spontaneously combust, or auto-ignite, without a spark from the engine. The aircraft was becoming a flying bomb simply by virtue of its speed. McCoyan solved this by using the fuel not just for propulsion, but as a colossal, circulating heat sink. The entire fuel load was pumped around the exterior of the airframe before being fed to the engines. This complex plumbing system cooled the skin, but in return, the fuel itself reached temperatures that made it incredibly volatile. The political imperative. The engineering teams at Mikoyan detailed these three barriers: thermal, material, and chemical, to the Politburo. They explained, in cold, hard scientific language, that physics didn't want this aircraft to exist. It was too hot, too fragile, and too volatile. It was a technological gamble designed for brief, suicidal sprints, not reliable military service. But the Soviet Union did want it to exist. The political imperative of supremacy trumped the laws of thermodynamics. The MiG___ program was granted unlimited resources. The engineers were ordered not to solve the problems, but to circumvent them, to find a way to fly fast enough, often enough, to deter the Americans and silence the criticism from Moscow. The result was the creation of a machine that was less an aircraft and more a controlled, self-destructing experiment. The pilot was the meat in the scientific sandwich, a human fuse in a missile of steel and fire, forced to fly the very edge of the flight envelope where physics, and survival, ceased to matter. Following the frantic, politically charged mandate from the Kremlin, to create a machine of absolute air superiority that defied the laws of physics, the engineers and designers at the Mikoyan-Gurevich Design Bureau OKB 155 threw themselves into the monumental task. They were not building an airplane. They were assembling a high-speed pressure cooker, a vehicle designed for brief, suicidal sprints beyond the known limits of the atmosphere. The first prototype, designated YE-155, emerged from the dark, cavernous assembly hangars near Moscow with a heavy, ominous presence. Its sheer scale dwarfed the accompanying MiG-21s, and its unusual, brooding profile, more like a weapon than a conveyance, immediately set it apart. The engineers, men who had previously christened their aircraft with poetic names like Swallow or Fishbed, had no illusions about the nature of this creation. They quickly gave the jet a grim, unofficial nickname that spread in hushed tones through the workshops: Bees, the Demon. Because nothing polite, nothing descriptive of rational aviation, could truly capture the essence of what they had created. The anatomy of annihilation. The MiG___ prototype was an assemblage of extremes, a triumph of brute force material science over aerodynamic elegance. 1. The power plant. Twin train cars of fire. At the heart of the Demon were its engines, the twin Tumansky R-15 B-30 after-burning turbojets. These power plants dictated every design choice, every compromise, and every sacrifice made on the aircraft. The R-15s were not small. Each engine was the size of a small train car, massive, heavy, and engineered for maximum thrust, not efficiency or longevity. They were designed to gulp down an unimaginable amount of air, compress it, and turn it into sheer, raw speed. Their thrust-to-weight ratio was phenomenal, but their cost was thermal ruin. The operational environment of these engines was so hostile that engineers calculated the average working life of a turbine blade at maximum afterburner, the speed necessary to catch the state Route 71, to be measured in mere minutes before the metal began to yield. The aircraft would be flown for a specific mission, and the engines would be immediately replaced, treated as expendable power capsules rather than durable machinery. 2. The fuel system. The silvered lifeline. Fuel management in the MiG_ was a matter of life and death, not just for the mission, but for the aircraft's structural integrity. As detailed in Part 2, the fuel itself, the high flashpoint kerosene T6, was used as a circulating coolant. The fuel tanks, massive bladders housed in the fuselage and wings, were not merely containers. They were elaborately engineered heat exchangers. Their exterior was wrapped in a special, high-purity silver coating, a shining, metallic sheath beneath the outer skin, specifically designed to reflect the intense radiant heat generated by the engine bays and the kinetic heating of the fuselage. This silver lining was a desperate measure. It was intended to buy the T6 fuel a few extra degrees of safety before it spontaneously combusted. The entire plane was essentially flying on the volatile edge of explosion, its fuel load acting as a colossal, pressurized refrigerator for the rest of the airframe, before being superheated and dumped into the furnace of the R-15 engines. 3. The eyes of the beast. The failing cone. The nose cone of the prototype was a large, conical bulge housing the TSAPLIN-25 radar system. This radar, developed in parallel with the aircraft, was intended to be the ultimate intercept guidance system, capable of tracking a high-altitude target traveling at Mach 3+ while simultaneously locking onto its massive, heavy air-to-air missiles. However, the radar was plagued by its environment. The intense heat of the nose cone, transmitted through the dielectric radome, created crippling electronic noise. The high-powered bursts necessary for long-range tracking created a feedback loop that overwhelmed the cooling systems. In ground tests and early low-Mach flights, the radar system never worked for more than 8 minutes before critical components would overheat and shut down. 8 minutes was the calculated window needed to climb to intercept altitude, acquire the target, fire the missiles, and begin the turn for home. The reliance on this fragile, failing radar system meant that every mission was a race against electronic oblivion. 4. The skin. The chrome black shroud. The most visually striking element of the Demon was its exterior. The primary airframe was constructed of specialized nickel-steel alloy, a necessity due to the extreme heat. But the final layer, the aesthetic and thermal defense of the aircraft, was a strange chrome black alloy coating. This coating was an experimental ceramic metallic composite designed to withstand the brutal thermal stress of Mach 3.5 flight. It was highly reflective and thermally resistant, but it had a catastrophic flaw: it was brittle. As the aircraft heated and cooled rapidly, the external layer didn't flex like aluminum, it shattered. When the jet was hot, the skin was taut and functional. But during the cool-down phase after a high-speed run, the engineers noticed the coating would begin to crack, shed, and flake like scales under heat. The pristine, black surface of the MiG___ prototype was constantly degrading, shedding its protective layer after every high-speed mission. The Demon was literally shedding its skin under the strain of its own ambition. 5. The cockpit. The quartz prison. The pilot's prison was the cockpit, and it was a masterpiece of compromise. The canopy, the pilot's window to the outside world, presented the final, most terrifying thermal challenge. Standard high-altitude acrylic or even laminated glass would simply melt or severely distort under the sustained temperatures generated by the friction of Mach 3+ air moving over the canopy dome. The solution was a radical, desperate choice. The canopy was built using specialized quartz glass. Quartz, possessing an exceptionally low coefficient of thermal expansion and a higher melting point than conventional glass, was the only material that could survive the immense heat generated by the speed. It was thick, heavy, and expensive, but it offered the pilot a narrow, distorted view of the world that was rapidly trying to kill him. The pilot was encased in a quartz and steel cocoon, sealed off from an external world of violent heat and hypersonic wind. The first ride. Imprisoned by velocity. The honor and the burden of piloting the first high-speed test flights fell to a select, terrified few. One of them was Colonel Yuri Pleshkov, a legendary PVO pilot known for his steel nerves and impeccable technical knowledge. Pleshkov's mission log entry, detailing his first push past Mach 2.5, is a testament to the sheer violence of the machine. On takeoff it felt like nothing. The acceleration was smooth, almost like riding an elevator. The R-15s were quiet in the lower atmosphere, powerful but controlled. The initial stages were deceiving. The MiG__, owing to its massive power-to-weight ratio, was a rocket on the runway. But as the aircraft ascended and pushed toward its operational envelope, the physics began to exert its terrible toll. Then at Mach 2.5, the aircraft began to scream. Not the engine noise, but a high-pitched, metallic shriek that seemed to come from the entire airframe. The whole jet vibrated like it was trying to tear itself apart. This was the thermal flutter, the sonic wind buffeting the airframe. The stress was causing micro-fractures in the non-flexible steel alloy fuselage, and the entire structure entered a low-frequency, powerful vibration, shaking the pilot violently inside his harness. Pleshkov described it as trying to hold onto a giant, rapidly ringing bell. The expansion and the trap. The critical threshold was Mach 3. This was the speed where the thermal expansion of the materials became dangerously profound. The engineers knew the steel alloy expanded under heat, but the scale was alarming. At Mach 3, the fuselage expanded by a measured 7 centimeters, nearly 3 inches, in total length. This expansion had a terrifying side effect on the cockpit. The frame warped just enough to lock the pilot in. The escape hatch and the cockpit canopy mechanism, designed to function within millimeters of tolerance, were now jammed tight by the heat-induced warping. The pilot, pushing the machine to its limit, became a prisoner inside his own jet. The speed that gave him power simultaneously stole his freedom, turning his quartz and steel cocoon into a hermetically sealed, airborne coffin. The cool-down lottery. The danger did not end when the mission was over. The MiG had to descend rapidly from its high Mach sprint, but it could not be rushed onto the ground. If the pilot landed the jet before the aircraft cooled to its normal, pre-flight temperature, the massive steel airframe would contract unevenly. Different metals, cooling at different rates, would exert massive, internal stresses on one another, threatening to twist the airframe like a pretzel, bending the wing spars, cracking the engine mounts, and utterly destroying the structural integrity of the fuselage. The cooling process required a long, slow descent, followed by an hour-long taxiing period, keeping the engines running at minimum power to ensure a slow, even thermal release. Every landing was a gamble. Land too soon and the plane would rip itself apart, linger too long in the air and the dwindling fuel supply would give out. The MiG was the embodiment of the Kremlin's desire, a perfect killing machine, a terror to its enemies, capable of impossible speed and range. But, ultimately, it was also a perfect killing machine for its own pilots, a hyper-speed trap that used the laws of physics to seal its victim inside a screaming, flaking, thermal prison, forcing him to ride a self-destructing rocket back to Earth. The internal struggle over the MiG-the Demon, came to a head in the summer of 1968. The political pressure to demonstrate the jet's superiority to the Kremlin was immense, overriding the desperate warnings of the Mikoyan engineers. They had constructed a monster. Now they had to prove it could perform its central, terrifying mission, to achieve speeds that made the American state Route 71 Blackbird look like a biplane. The stage, Sery-Shogun, 1968. The trial was conducted far from the sensitive borders of the Baltic, in the vast, desolate stretches of the Sery-Shogun anti-ballistic missile test site in the Kazakh SSR. This remote location was chosen for two critical reasons: the sheer size of the testing range, which offered hundreds of kilometers of open airspace for a potentially runaway machine, and the presence of advanced, high-velocity tracking radars designed for missiles and warheads, not aircraft. The primary objective of the test, code-named Icarus Leap, was to achieve and sustain Mach 3.5 for a minimum of 5 minutes, then push toward the theoretical, catastrophic maximum of Mach 4. To lend a sense of formality, and, perhaps, to provide a terrifying frame of reference, the Demon was assigned a pair of operational MiG-25 feet Foxbat interceptors as escorts. The MiG-25 itself was, at the time, the world's fastest fighter, a legend built on speed and high-altitude performance, capable of sustained Mach 2.8. But these escorts were a formality, a tragic joke. No aircraft on Earth could keep up with the Demon once its R-15 engines were uncorked. The MiG-25s were there only to observe the takeoff, confirm the initial acceleration, and, if the worst occurred, report the location of the wreckage. The ascent and the scream. The day of the test was clear, the sky over the Kazakh steppe a deep, perfect blue. The MiG its flaking chrome black skin absorbing the desert heat, looked menacing next to the relatively pristine silver of the two escort fighters. The jets climbed together, the MiG-25 pilots, Captains Kozlov and Volkov, carefully matching the heavy, straight-line ascent of the prototype. The chosen test altitude was 23 kilometers, 75,000 feet, the cruel, thin air of the lower stratosphere, well above the tropopause. At this height, the lack of air density meant minimal drag, allowing the R-15 engines to truly demonstrate their raw power. At the designated point, a featureless coordinate over the dried-out bed of Lake Balkhash, the mission controller's voice crackled in the cockpit of the Demon. "Icarus, you are cleared for full power. Execute." Colonel Pleshkov, strapped inside his quartz and steel prison, moved the throttles past the detent and into the afterburner zone. The escorts, flying in a wide V formation, watched the prototype react. They saw the flame. Two immense cones of pure, blue-white propulsion erupted from the nozzles of the R-15s, expanding in the thin air to create a terrifying vision of sheer, unbridled energy. The Demon surged forward, immediately leaving the MiG-25s behind. They heard nothing. The speed differential was so immense, and the sound was trapped so far behind the jet by the sheer velocity of the aircraft, that to the escort pilots, the ignition was a silent explosion of light. The sound, an immense, raw thunderclap, would follow the Demon's retreat by over a minute. They never saw it again. Within 20 seconds, the Demon was a rapidly diminishing speck of light, accelerating faster than any pilot in history had ever witnessed. Kozlov and Volkov immediately broke formation and turned for base, their mission already complete and their jaws hanging slack from the spectacle of impossible acceleration. The telemetry nightmare. In the blockhouse at Saryshogin, the dedicated telemetry officers were glued to their screens, tracking the MiG___ through the advanced missile tracking radar. These systems were built to handle the Mach 10 speed of an incoming warhead, but they struggled with the sustained, accelerating velocity of the massive demon. The numbers flashed across the screens, moving with frightening fluidity. Mach 3.4, a successful cruise speed for the SR-71. Mach 3.6, a speed that would tear the wings off a conventional fighter. Mach 3.8, the theoretical red line limit of the MiG-25. Mach 4.0, then, the calm, disciplined routine of the test facility broke into panic. The engineers knew the official warnings by heart. At Mach 4, the airframe should have disintegrated. The nickel-steel alloy was rated for that speed, but the structural welds in the fragile quartz canopy were not. The plane was running at its self-destruction limit. At Mach 4.2, the pilot should have blacked out. The G-forces associated with even the slightest atmospheric turbulence at that speed were enough to overwhelm the specialized, pressurized flight suit. But the tracking signal didn't disappear. It was steady, strong, and terrifyingly fast. Mach 4.4. Then, suddenly, the tracking officer yelled, "Contact lost. It's gone." The vanishing act, outrunning the radar cone. The signal did not vanish because the aircraft was destroyed. It vanished because it had just pulled off a feat that was unprecedented in aviation history. It simply outran the radar cone. The tracking radar at Saryshogin, though designed for high-velocity targets, operates on the principle of pulse repetition frequency (PRF). It sends out a pulse and waits for the return signal. The electronics processing the return have a limit to the rate at which they can accurately calculate speed and position. The MiG had not only surpassed the thermal limits of its airframe and the physiological limits of its pilot, it had accelerated past the maximum radar velocity (MRV) of the tracking system. The aircraft was moving so fast that the radar return signal was subjected to an extreme, sudden Doppler shift that simply exceeded the system's ability to interpret the data. The radar didn't register a failure. It registered a phenomenon it wasn't programmed to understand, an object that achieved velocity greater than its own measurement capability. The jet had literally accelerated faster than the computer system could calculate. For the first time in aviation history, a jet had achieved true, temporary electronic invisibility not through stealth, but through sheer, brutal speed. The return and the dread. The flight time was scheduled for 20 minutes. The minutes dragged into an hour. Every officer in the blockhouse assumed the catastrophe scenario. The demon had disintegrated and was now a shower of molten steel raining down onto the steps. Search and rescue helicopters were scrambled. Then, 45 minutes after it was scheduled to return, a faint, almost desperate radio call broke the silence. Icarus descending. Holding pattern established. I have visual on the airstrip. The MiG returned. It flew along, slow holding pattern, descending with the required thermal discipline, the cool-down lottery described in Part 3. When the aircraft finally taxied onto the apron, the scene was one of shock and horror. The pilot, Colonel Pleshkov, was unconscious in his cockpit, his high-altitude flight suit permeated by sweat and heat. He was immediately pulled out and rushed to the flight surgeon, suffering from severe thermal overload and exhaustion. His core body temperature was dangerously elevated. He had survived, but barely. The airframe. The plane was a wreck. The chrome-black coating was flaking off in large sheets. Most terrifyingly, the aircraft's nose was partially melted. The friction at Mach 4+ had caused the steel nose cone and the exposed seams of the quartz canopy to reach temperatures that caused the metal to permanently deform and slump. But it was whole. It flew. It reached an impossible speed, vanished, and returned. The NATO intelligence picture. Fragmented fear. On the western side, intelligence gathering on the demon was slow, agonizing, and terrifyingly incomplete. NATO had no full visual, only fragments of electronic chatter, telemetry noise, and the unsettling testimony from the Baltic patrol pilots. The codename they assigned to the demon was never used in official documentation, but was a grim moniker adopted by the ELINT operators and analysts at NSA and GCHQ, the Widowmaker of the East. Their knowledge was a terrifying mosaic. A mysterious high-speed jet, confirmed by multiple radar anomalies, including the impossible speed over the Baltic and subsequent, sporadic satellite trackings. The speed was so high they assumed the Soviets were lying about their own jet fuel quality. Unusually high engine casualties. Intercepted Soviet logistics chatter revealed a catastrophic, unexplainable rate of failure for the new R-15 engine series. The order logs demanded replacements far exceeding any known operational rate for a new aircraft. Pilots treated for thermal trauma, medical radio traffic, filtered through the sensitive eavesdropping facilities in Turkey, showed a spike in urgent treatment requests for Soviet pilots, often citing burns, extreme dehydration, and heat exhaustion, symptoms wholly inconsistent with normal high-altitude flight. NATO did not know the aircraft's speed, but they knew its cost. It was a plane that consumed its own parts and injured its own men, yet still flew faster than any NATO asset. The fear was that the Soviets would simply accept this human and material cost to achieve strategic dominance. The painful realities. The Soviet internal assessment. For Soviet planners, the hard data stripped away the nationalist glory. The internal assessment of the MiG program was devastatingly honest. The machine was a triumph of acceleration, but a systemic failure as a weapon system. The jet was shackled by 5 fundamental, interlocking problems. At Mach 4+, the Doppler shift caused by the jet's immense velocity rendered standard VHF and UHF radio communications practically useless. The frequency shift was so profound that ground stations struggled to lock onto the pilot's transmissions, and the pilot's own radio receivers were overwhelmed by the noise and distortion. The pilot was flying in a communications black hole, truly alone, unable to receive critical guidance or transmit his status. The kinetic energy accumulated by the massive, heavy aircraft at Mach 3+ was unforgiving. Any sharp turn or high G maneuver would result in lethal G forces for the pilot exceeding 12 G and, more importantly, would subject the nickel-steel airframe to unacceptable structural loading. The wings would either snap or permanently warp. The machine was designed for a single, terrifying, straight-line sprint to the target. If the target moved, the MiG could not follow. The R-15 engines were pushing past the material limits of the metals. Internal reports showed that on any given high Mach sortie, there was a nearly 1 in 3 chance that one of the twin engines would suffer a catastrophic failure, a turbine wheel exploding or a compression chamber cracking, turning the jet into a single-engine, high-altitude wreck miles from base. The specialized cooling systems and pressurized suit could not fully negate the thermal hell of the cockpit. The average pilot could endure the Mach 3.5+ thermal envelope for no more than 20 minutes before acute physical degradation and unconsciousness set in. The human element, the very reason the jet existed to guide the missiles, became its shortest fuse. The TSAPLIN-25 radar, the failing nose cone system, was confirmed to be useless for sustained high Mach interception. The 8-minute limit was generous. After 10 minutes, the system was prone to complete thermal shutdown, leaving the pilot to find a Mach 3 state Route 71 visually, a literal impossibility. The paradox of victory. The MiG was relegated to mock combat simulations against remote-controlled drones mimicking NATO aircraft. The results were paradoxical. In simulated combat, it won every engagement. By simply leaving the battle entirely, it could achieve its missile-firing envelope, accelerate past the target, and vanish before the enemy had time to acquire a lock or initiate countermeasures. But the victory was meaningless. The aircraft was too fast to effectively engage the target, too brittle to maneuver, and too short on endurance to verify the kill. The political pressure to transition the Demon from a reckless experiment into a viable strategic weapon was immense. The Kremlin was tired of reading reports about the SR-71's unhindered surveillance flights. The decision was made to demonstrate the revised prototype for the highest echelon of the Soviet military-industrial complex and the Politburo, confirming its technical readiness for limited production. The stage was set at the Zhukovsky Air Base outside Moscow, the Soviet Union's premier flight test facility. The demonstration was attended by the Chief Marshal of Aviation, the Minister of Defense, and the heads of the PVO. The air was thick with the tension of high-stakes politics and the knowledge that the machine on the tarmac was the most dangerous creation of the entire Soviet aviation history. The pilot chosen for this ultimate display was a veteran test pilot, Major Alexander Yevgeniev. He was fully aware of the 20-minute survival limit and the 30% chance of engine failure. His mission was simple: Demonstrate a Mach 3.5 intercept profile, hold it for 3 minutes, and return smoothly. The acceleration that would not end. The demonstration began with the choreographed precision of a state ceremony. The jet took off cleanly. The immense thrust of the twin R-15 engines slammed the heavy steel monster down the runway, lifting it into the air in a surprisingly controlled, rapid ascent. It climbed smoothly. Major Yevgeniev pushed the throttles, climbing rapidly through the dense lower atmosphere toward the operational altitude of 25 kilometers (82,000 feet). Then, as the jet entered the thin air of the stratosphere and the afterburners were fully engaged, the expected control problems began to reverse. The modifications, the strengthened fuel pumps, the improved high-pressure intakes, were working too well. At Mach 3.7, according to the test profile, the immense heat and friction should have created a natural aerodynamic resistance that forced the pilot to throttle back slightly, or at least caused the acceleration rate to level off. It should have slowed. It did not. The telemetry data flowing into the bunker showed the acceleration curve continuing its upward trajectory, smooth and unstoppable, as if the aircraft had passed a critical threshold where drag ceased to matter and the sheer force of the R-15s took over. The demon was feeding itself into a thermal runaway. The electronic silence. In the control bunker, the measured silence gave way to frantic radio calls. At Mach 4, radio calls went unanswered. Major Yevgeniev was likely fighting the catastrophic effects of high Mach turbulence and heat, unable to spare a hand for the radio. The control frequency was filled with a desperate, growing static. At Mach 4.3, the tracking cameras failed. The external high-speed cameras, designed to film the high-temperature performance, were blinded. The thermal signature of the aircraft was so intense, and the distortion of the air around the fuselage so profound, that the lenses were instantly fogged and the image degraded into a blur of light and heat. The last visual data confirmed the terrifying speed. The nose cone was glowing a dull cherry red from kinetic heating. The senior officials in the bunker watched the radar screens with growing horror. They were witnessing not a demonstration of control, but a demonstration of uncontrolled escalation. The Soviet High Command immediately grounded all test flights and initiated a massive, covert search and rescue operation. No wreckage was ever found. The failure to find the debris, particularly the massive R-15 engines, led to two enduring theories about the demon's final moments. Theory 1. The catastrophic implosion, the material's failure. Some engineers believed the pressure and heat proved fatal at the final moment of peak acceleration. Hypothesis. The structural stress limit was breached. The intense vibration at Mach 4+ caused the primary airframe welds to fail. The aircraft did not explode outward. The intense ram pressure and dynamic forces of the hypersonic slipstream instantly crushed the fragmented remains of the fuselage. Conclusion. The machine was instantaneously converted into a cloud of molten dust and microscopic fragments at 30 kilometers altitude, a phenomenon known as hypervelocity disintegration. This would explain the lack of debris, as the remnants would be scattered over thousands of square kilometers of the desolate Siberian north, too small to be picked up by radar or visual search. Theory 2. The ballistic arc, the unintentional space shot. This theory was championed by the aerodynamicists and propulsion experts, the men who knew the true power of the R-15 engines. They looked not at the structural stress but at the terrifying upward trend of the final acceleration curve. Hypothesis. Major Yevgeniev, knowing his cockpit was failing and his airframe was ripping itself apart, chose the only path that might save his life, or at least avoid a low-altitude breakup. He pulled the nose up slightly, converting the terrifying horizontal velocity into vertical velocity. Conclusion. The immense R-15s, receiving that final, smooth burst of fuel from the runaway pumping system, drove the MiG straight up, converting the Mach 4+ speed into pure ascent. The jet climbed until its air-breathing engines flamed out in the vacuum of near space, sending it into a ballistic arc somewhere over the Arctic. It might have impacted a remote, uninhabited glacier, or, more terrifyingly, achieved a long, eccentric orbit, making it a permanent, unguided piece of orbital debris. The fact remained that the Soviet Union had launched a manned machine that disappeared into a region of space its own rescue teams could not access. The humiliation was absolute. The program was shut down within 72 hours. The surviving engineers were scattered, the design files seized by the KGB, and the MiG was officially purged from Soviet aviation history.